Okay, good morning. This is Professor David J. DelosReyes. I'm using my new eyeglass for this morning. This is what they call this progressive and a bifocal, and it's a prescribed eyeglass for my eyes. Okay, the date for today is December 2, 2023, and the time is around 2 a.m. Okay, my topic for this morning will be trigonometry, lesson number 34, and I will be presenting second solution from the previous lesson. From the previous lesson 33, I presented the first solution. So for this morning, we will be solving the same problem, but we will present another type of solution. Okay, let's proceed. The subject matter for this morning will be trigonometry, lesson number 34, and the title of the topic is example problem on sine/cosine of two angles, meaning the identity that we will be using in the solution of the problem will be by using the sine and cosine of the sum of two angles. The last time around, we used the so-called double angle formula. A double angle, sine and cosine of a double angle. Okay, so for this morning, I will be presenting another solution by using the other identities, that is sine and cosine of two angles. Okay, let's proceed. The given problem is, or the given trigonometric equation is the sine of the quantity x plus 45 times the cosine of x plus 45 is equal to 1/4. The problem is asking what will be x equal to. What will be x in terms of radians or degree? It doesn't matter. As long as we are consistent with the unit of the angle. If the given angles here are in terms of degrees, what will come out should be in terms of degrees. Okay, let's try to bring out the solution. Let's try to expand first the sine function, this one. So we will be using sine of two angles. So we'll try to bring out the expansion of the sine function of the quantity two angles. Sine of the quantity, the angles will be the unknown x plus 45. So these are two angles, and this is under sine function. If we try to expand this one, we finished this one already. Sine, cosine, cosine, sine. If this is plus, this should be plus. So sine of x, cosine 45, plus cosine x, sine of 45. And here, the cosine and sine of 45 is readily available. This is 0.707, this is 0.707. Or this is actually, for an angle to be 45 degrees, it's a special angle. The tangent of 45 is actually 1 over 1, so the hypotenuse will be square root of 2. So both the sine and cosine will be the same, and that is actually with the value 1 over square root of 2, or this is 0.707. So this is 0.707, and this is also 0.707. Okay? Oh, what's next? Okay, I'll try to erase the rough graph, okay? So it will look nice when somebody watches our lecture on YouTube. Okay? So in here, we are now given the cosine of 45 degrees. It is 0.707. And again, the sine of 45 degrees, it's still 0.707. So we expedite a little bit. There is a 0.707 here. There is a 0.707 here. We factor out. So the common factor is 0.707. What remains will be sine x under quantity sign plus cosine of x. This is sine, this is cosine. We bring out 0.707, we bring out 0.77. Oh, let's try to expand the cosine of x plus 45 degrees. So this now falls under the cosine, okay, of two angles. That is the cosine of the quantity x plus 45, two angles, right? It should be cosine, cosine, sine, sine. If this is plus, this should be minus. So cosine of x, cosine of 45, sine of x, sine of 45. And again, there is a cosine 45 here. There is a sine of 45. They are both 0.77. We expedite a little bit our simplification. There is a common factor 0.707. What remains on the quantity will be cosine of x minus sine of x. The first one is sine of x and cosine of x. So substituting, meaning the resulting expansions, we place it on the original problem. So sine of the quantity x plus 45 will be this value here. And the cosine of the quantity x plus 45 is actually this one here. Okay? Then we'll try to, and this should be equal to 0.25. The operation is multiplication, right? Let's try to expedite a little bit. We multiply all the constant terms on the left. 0.707 times 0.77 is actually 0.5. Right? Then what will come out will be sine of x as cosine of x times the quantity cosine x minus sine x. And this should be equal to 0.25. Okay, let's try to eliminate this 0.5 here on the left. So we will multiply all the terms by the reciprocal of that one, that is 1 over 0.5. So this one here cancel with this. So the left hand side now is free of a coefficient, right? The coefficient is just 1 now. And 0.25 over 0.5 will be 0.5. And for the left hand side, we distribute. We are multiplying two binomials that contains what we call this trigonometric function. So sine x times cosine x will be sine x cosine x, right? Sine x times minus sine x will be minus sine square of x. This is a plus and a minus, so this should be minus. Cosine of x times cosine of x will be cosine square of x. Cosine of x times minus sine of x, minus sine of x, cosine of x. Okay, we just interchange anyway, the operation is multiplication. Okay, so that's the correct expansion of the left hand side. We are expanding two binomials that contains a trigonometric function. And luckily this sine of x cancel with this. This is a plus and this minus. This is a plus. This is a minus. Right? Then we will write this one first. Minus sine square of x. We will replace the sine square of x from the first trigonometric identity cosine square plus sine square is equal to 1. We could compute for sine square from there. It will be 1 minus cosine square of x. So we will replace sine square of x by the quantity 1 minus cosine of square of x, and this should be equal to 0.9. Expediting, cosine square, okay, this is a minus and a minus, it's also a cosine square, so that will now be 2, right? A minus 1 times a plus 1 will be a minus 1. We put it on the right, so this is now a plus 1. Therefore, cosine square of x now, 1 plus 0.5 will be 1.5. Then we will multiply this by 1/2. So this one cancels. Cosine square of x equal to the sum of 0.5 plus 1, this is over 2. 1.5 times 1/2 will be 1.5 over 2. Cosine square of x will be 0.75. Okay, let's try to compute for cosine of x without this square here. So we will raise this to 1/2. Okay, laws of exponent. So this one here, cancel with this. Left hand side, it will be cosine x. For the right hand side, 0.75 raised to the 1/2 is the square root of 0.75. So cosine of x, the sign of the term inside the radical is a plus. So if we try to take the square root, it will be plus or minus. So cosine of x will be plus or minus 0.866. And to compute for x without the cosine term here, okay, we will take cosine to the minus 1 of both sides, right? So cosine to the minus 1 of cosine to the plus 1 of x, this cosine of x cancel with this. Left hand side, it will just be simply x. Right hand side, the other equivalent of arc cosine, cosine to the minus 1 is just arc cosine, right? So the right hand side, it will be the arc cosine of the quantity plus or minus 0.866. And if we try to use our calculator, this is a plus and minus. So since this is a quadratic equation, the value of x should have a value 2 or 2 values. So x now will be plus or minus 0.866. So by using the positive sign, the first answer here is plus 30 degrees. Like our answer from the previous solution. What comes out from the previous solutions, it is not just quadratic, it is just a linear thing. It is plus 30 degrees. So this is actually the first answer from the previous solution, the first solution. And by using the negative sign, okay, it's negative 30 degrees, so this will be our answers now. Meaning to say, for this given trigonometric equation, the correct answers will be plus 30 degrees, and the other value is negative 30 degrees. Okay, let's try to check the validity of the answer. By using the original equation, if we try to substitute or plug in x1 equal to 30 degrees, x plus 45 will be 75 degrees, right? And this is 75 degrees. Sine of 75 degrees times cosine 75 degrees. Will it be equal to 0.25? This is 0.966. 75 degrees is almost, it is very near 90 degrees, so the value is very near 1. It's 0.966. And cosine of 75 degrees, it's a small value, it's 0.259. Will it be equal to 0.25? The product of this is, if you try to use your calculator, it is really 0.25 equal to 0.25, it's true. So this is correct. Let's try to check the validity of the second answer. If x2 will be negative 30 degrees, if we try to plug in negative 30 degrees here, what will come out will be 15 degrees and 15 degrees. So this is sine of 15 degrees times cosine of 15 degrees. Sine of 15 degrees is a small value. It's very near 0. So the value is very near, it's not 0, but it's almost a small number. It's 0.259. Okay? And cosine of 15 degrees, cosine of 0 is actually 1. So if the angle is near 0 degree, the value is almost 1. It's not 1, but it's almost 1. It is 0.966. It is actually the reverse of this, because 75 and 15 are actually complementary angles, right? The sine of the other one is actually the cosine of the other one. So 0.259. So it seems we just interchange this one, right? 0.259 times 0.966 will it be equal to 0.25. And 0.25 is equal to 0.25 in true. So the second answer is actually correct. Okay, that's it, guys. That's how we produce solution number 2 by using the expansion of the sine and cosine of two angles. Okay, this is Professor DavidJDelosReyes. I'm wearing my new prescribed eyeglass for this morning. Good morning.